Hello, I am Associate Professor Dr. Kok Yet with the Department of Computer Science and Information, King Mongkut University of Technology, North Bangkok, Thailand. I'm presenting my resource, the IoT-Enabled Laundry Drying Rack for Smart Home. In this study, we propose the design and implementation of an IoT-enabled laundry drying rack specifically for smart home applications. It is particularly suitable for residents of the tropical regions, where drying clothes mostly depends on sunlight. Here is the final prototype and the mobile application screens to monitor and control the drying rack. As we know that laundry drying practices vary around the world, influenced by the climate, culture, infrastructure, and technology. Generally, drying methods can be divided into two main categories: air drying and machine drying. Air drying involves hanging clothes outside on a clothesline or drying rack, allowing them to dry through natural processes, sunlight, wind, and ambient air circulation. The objective of this study were to design, develop, an IoT-enabled laundry drying rack for smart home in tropical regions, and design, develop a mobile application to control the drying rack. Alright, let's move on to the system architecture. There are three main components: a server, hardware or drying rack, and a mobile application. The hardware consists of microcontroller, sensors, and actuator. We employed two types of sensors, a rain sensor and humidity sensors. The hardware is monitored and controlled by a mobile application, all connected using Wi-Fi and through services Firebase and Line Notify. The hardware or drying rack is designed to hanging freshly washed clothes. It consists of a frame and a sliding rail system. The carriage automatically retracts the clothes when they are dry or when rain is detected. The clothes hanger is a standard garment hanger equipped with a humidity sensor located at the single point of the hanger, and two humidity sensors are attached to the clothespins, where we attach to the thickest parts of the clothes. The laundry dryness, or HD, index is calculated using a relative humidity measurement by this formula. H1 and H2 are from the clothespins, and HA is the humidity level of the surrounding environment. When the desired dryness level is reached, the drying rack automatically retracts. The mobile application interface consists of two main sections: the dashboard and the setting. The dashboard and the settings. The dashboard displays real-time information about current weather conditions and the operational status of the drying rack. Here's the schematic diagram. The carriage is driven by the high-torque geared motor and a belt system. Two limit switches are installed at the both ends of the track to monitor and restrict the carriage movements. The evaluation focused on two key aspects: humidity measurements result and overall system performance. For the humidity measurements result, we compared the ambient humidity levels from our system with the reported by two weather services, AccuWeather and the Weather Channel. Our findings show that the sensor's humidity readings aligned consistently with the values provided the service. Also, we analyzed the measurements and found that the differences did not exceed 7%. So, we conclude that the humidity readings from the clothes drying sensor are reliable for practical use. The sensor achieved an accuracy rate of 97.8%. In conclusion, in this study, we designed and developed an IoT-enabled laundry drying rack utilizing IoT technology. This system is particularly well suited for populations living in the hot and humid climates, where sunlight is primarily used for drying clothes. The clothes hanger utilizes standard hangers equipped with the humidity sensors, one at a specific location on the hanger and two located on the clothespins. The user can choose operation modes using mobile application between auto and manual. Alright, that's all for the presentation. Thank you.